So good morning, good afternoon from the UK. My name's Del Cheeseman, as I said earlier. Welcome to this event, How to Get Started Using Predictive Intelligence to Radically Improve Your IT Service Experience. What we're going to do before we get started, we're going to go through our housekeeping. So again, we always put this up. This is our safe harbor notice that we may or may not discuss forward-looking statements or directions of the platform and the products. Please make sure that this is our legal statement to say, please don't plan your deployments features ahead because again, things could move. So without that, next slide. This, for me personally, is my last live on ServiceNow for this section of the year. But we will be doing future webinars and meetups on the virtual agent and predictive intelligence and performance analytics and more. And the more that I'm going to call out is I've actually put a request into the team that one of the next webinars that I will do is all around the natural language understanding, the NLU. That's a big portion of predictive intelligence, and I think it has enough for it to be on its own. So that's what's coming up. So please keep a check on upcoming webinars and meetups. From a housekeeping perspective, could I please ask that you stay on mute? There will be Q&A after the presentation. Please use the Q&A feature to ask any questions. I'll be monitoring that through the session. If you do come off mute to ask a question, please feel free to introduce yourself, what company you're from, where you are in your deployments. The session will be recorded and shared on the ServiceNow community after the session. And after the session ends, you will be prompted to fill out a short survey. We really do appreciate your feedback. So, as I said, my name's Del Cheeseman, and I'm going to turn on my camera very quickly so you can all see my ugly mug. Here I am. Good afternoon. And I work in the Now Intelligence team and as a senior advisory solution consultant. So our main responsibilities is really in the hyperautomation view. And for people who don't know about hyperautomation, it's our new strategy, which encompasses the core technologies that we look after, which is performance analytics, virtual agent, predictive intelligence, AI search, process optimization. So, we do take a look at all the cool products. So with that, I'm going to move through to my first slide. And the moment people think about AI, they either think of the film that has Bruce Willis in and that child who's a robot, or they think about this film because they think it's a lot of code that goes everywhere and it all just magically comes together. So I always like this slide just to sort of ease us in, but we're going to go through AI. We're going to go through the core competencies, but this session is more in the back end of how easy this thing is to actually deploy at speed and get the benefits, rapid. So a couple of things I always sort of see a lot of is when we first talking with customers, challenges faced in these organizations is, we start off with their mean time to resolve is poor. And we start looking into that. And one of the things that predictive intelligence can definitely come along and help is, improving those tickets that get stuck in the world of incident or ticket management. And when a ticket gets incorrectly assigned, it can sit there for a while till somebody picks up, realizes it's the wrong queue and moves it to the new queue. And 2 hours could have gone by. So that's where a lot of customers, one of their challenges is that they're getting calls incorrectly assigned, which is slowing their mean time to resolve. And ultimately, it's also, not helping on their CSAT scores. Technical assistance to support staff, again, where you've got this wealth of data in your platform, but again, providing that relevant information to the agent at that point in time helps expedite the agent. So as opposed to the agent looking for it, the predictive intelligence presents it to them. So again, this is helpful in major incident detection, in, presenting relevant records, providing similar changes or recommended changes, and so on. So it really does help. And for me personally, this is a real big win and is a real way of speeding up your delivery performance straight away, because Similarity Framework actually does no changes to the system. It's just presenting information. And then the other one that we see a lot of is unable to see larger reoccurring issues, because if you're in an organization that's generating 30, 40, 50,000 tickets a month, or you're generating over 1 million a year, you're seeing the big major ones, but throughout the year you could have smaller, what we say are not important issues, but accumulatively over the year they are a problem. So helping proactive problem management be able to find those cluster of records, and as well as that, being able to use one of our models or engines to be able to say, what, we want to see where we can shift left. Where are our virtualization records? Where are our virtual agent potentials? So these are a lot of the challenges that some of our customers face on a day-to-day basis. So the significance of AI and machine learning is, we all talk about the human mind is great at solving difficult issues and problems. But when you're faced with mountains of data, patterns are hard to find. Humans don't find that very easy. And so what we want to say is that imagine a world where you can instantly recall solutions to known issues and problems, quickly find those needles in the haystacks of relevant information, automatically make accurate assessments such as, where's the best place to put a task, or where's the best category. So this is where we start looking at your employees. Your employees would work faster and smarter, make better decisions, fewer mistakes, and giving them that time to focus on more meaningful work. For your business, that translates to higher productivity, lower costs, increased CSAT, and more motivated employees. So it's a less business risk. So this is where we start looking at what the AI solution is. And as you can see, it actually spans quite a wide range of our platform technologies. What we're going to focus on today is the machine learning frameworks, which are the 4 here. And we're going to show you how to get started with these very, very quickly. One of our other workshops one of our other live webinars we're going to do is going to focus on that middle section, that natural language understanding. In there, you've got the workbench, you've got the natural language processing, you've got querying, you've got understanding. So that's a big part of the virtual agent. And then over on the right-hand side, you've got the search and automation, where you're looking at the AI search, enhancing your search capabilities, bringing in index material, showing those genius results. And then the other one is the automation discovery. So for people who've been on the virtual agent live webinar, we talked about the automation discovery, being able to look at your data and present information of where you could look at shifting left on some of this. So this is the core purpose-built AI, which is directly embedded on our platform. So hopefully this is all making sense to you. But what can a lot of customers say to me, where do we start? How do you drive the transformation? And we put it down into 5 steps: establish, evaluate, identify, automate, and optimize. Now, again, the first one is pretty much where the mistakes or the success is going to come, because you have to establish the solid data foundation. You have to understand your data. Now, what I mean by that is, if you're looking at a modeling, and you understand the data of what you're looking at, it's that old adage of junk in equals junk out. So being able to sort of look at your data and go, okay, I want to filter out this chunk of information because that could skew my results. I've had scenarios where, we've looked at 2 years worth of data, but halfway through the year, they recategorized. So suddenly we're trying to do a category model based off 2 technically different sets of data, skews the results. So understanding your data foundation is the key to the success. Then you look at evaluate. And what we talk about evaluate is look at your service performance baselines. You know, where are you performing right now before you start bringing in this AI data? This can be achieved with PA, performance analytics, but identifying, you know, what is your current mean time to resolve? What are your current open without updates? What are your reassignment counts and so on? Then you start getting into your planning and your modeling. So identifying goals and pinpoint areas for improvement. So identify from the previous step, you're now starting to look at, okay, I'm seeing a reassignment issue. I'm seeing that my mean time to resolves are taking a long time. Why are they taking a long time? And so on. So when you start identifying goals, you want to pinpoint. So I want to reduce mean time to resolve. How can I do that? Get the tickets there faster. I can present records to my agents because that will help them resolve the calls faster. So this is where you're starting to pinpoint these. So with the automation piece, obviously utilizing something like clustering to be able to understand your automation candidates and actually applying them into the virtual agent world. Then you're looking to optimize, because once you've done it, you know, and you've been running with this, looking at your evaluate phase, now looking at your optimize phase, are we seeing a shift? Are we seeing that this thing is moving the dial? So these outcomes at the bottom is 42% of all requests in 2020 fell within 10 categories. This is an outcome. 75% of use cases were identical to the other ServiceNow customers. $21 million saved by automating the top 10 manual processes over 5 years, the virtualization. The 60,000 hours saved by automating the top 10 manual processes each year. So as you can see, you know, to achieve these successes, predictive intelligence does play a core in some of these. So what we're going to focus on again today is we're going to look at the core of these frameworks, which is classification, similarity, regression, and clustering. Now, for some people who've been on some of our PI courses already, webinars, you may have seen this a bit more, but the session that we're going to do now is a bit more under the hood, behind the scenes, the modeling, the training servers and things like that, just to show you, don't be scared by it. It's very, very simple. So again, classification, being able to get the ticket classified, categorized, assigned by basically looking at information coming in from a customer to be then showing you, you know, what priority it should be, what category it should be, what assignment group it should be. Then we're looking at the similarity. Now, the similarity framework for me personally, coming from an operational background of over 25 years, the framework of this capability is, you know, what challenges, and I've already touched on it, but agents spend too much time manually searching for incidents, you know, or related. So to help them to resolve an issue for a specific customer. So the solution is to be able to automatically recommend relevant incidents, present them with similar changes or recommended changes, detect major incidents. I remember many, many years ago when I was operational, is there was nothing worse than your customers calling you and telling you there's a problem and you didn't know about it. So having the modeling where it can see a pattern and then alert you to that, to say, in the last 10 minutes, I've noticed 3 other high impact incidents coming in. You may have proposed a major incident. So having that ability. So similarity for me is one of the quickest wins. The clustering framework. Now, the clustering framework uncovers opportunities for improvement with what's called unsupervised learning. So solutions that identify patterns and continuously segment them and group them with similar ideas. So in essence, the clustering framework is doing clustering analysis and shows you that clustering visualization. So it's learning from your records, and it's creating what's called clustering concepts and grouping records together to sort of let you see the big picture. So when I talked about the million records a year, and you've got these small amounts of records throughout the year, the clustering will pick up on that and group them together. So it actually helps proactive problem management. It can help understand where your virtualization is. And a lot of my customers in the UK who have deployed this, they actually use clustering, every quarter to look at, okay, we virtualized these conversations. Let's run clustering again and omit out anything that's virtual agent and see where our next roadmap of conversation for virtualization can come. Or you can also sort of say, what noisy records have we got? How many ITOM records have we seen in our incident space? Can we get rid of them, and put that down the ITAM or ITAM route? So this is what the clustering framework is about. And then the final one that we're going to look at is regression. So regression is the common supervised machine learning technique that can be used to predict continuous values based on a set of given criteria. So what's the challenge here? So time to resolution is pretty much a critical metric to ensure that you're efficient and your service management teams. And to deliver the best experience for your customer, a customer who asks a question and gets a good answer back within a few hours will almost always be more satisfied with the interaction. So the need here is organizations can improve their experiences for customers and efficiency across service management by correctly setting expectations. Monitoring, example, time to resolve helps set customer expectation, identify bottlenecks and areas where more attention is needed. So identify more complex incidents that require additional resources, and then flag the internal process that are associated with longer resolution times. So in essence, what I'm getting at here, what some customers are doing with this, the modeling is learning that numerical calculation of resolve time, and some of my customers are presenting that to their customers when a record is being raised. For example, in the virtual agent can call the regression model. So imagine the virtual agent, trying to resolve an issue. Then it gets to the stage where it has to log a call because it can't fix it. The ticket system is then triggered. It logs a call, but then it can then at that point call the classification framework, get it to the right assignment group. It also can call the regression model and say, based off your information, we're predicting that this could be fixed in 1.2 days or 1.5 hours, because it's looked historically at your fixed times and it's making a calculation prediction based off that. So hopefully that all makes sense. So what we're going to do is, before we get into this, the demonstration as such, or the back-end viewpoint, just think about these discussion points. If you're on your journey already, some of these may or may not be relevant, but getting started, where do we start to see benefits with PI and starting place for deployment? Well, I'll give you a clue: data. But getting started, for me, the quick win, again, I'll say it again, similarity. It doesn't change anything in the system. It's just providing information, and just getting that information to your agents faster can actually help speed them up. Speed your agent up, resolves calls faster, improves mean time to resolve, improves CSAT. So then the tuning, can we tune these models? Have we already done this? So that, building a model, can I tune the model? And then the one that I always finish on is continual cycle. Do we just set this and forget it? No, it's a continual improvement process. Every time the model's retraining, is the model better or worse? And this is where we talk about tuning and continual cycle. They are sort of closely linked. So what I'm going to do is I'm going to just stop sharing for a second while I switch screens. While I just do this, do we have any questions? Okay, so I'm going to stop sharing and I'm going to reshare on my other machine. Okay, so hopefully you can see my instance. Now, again, visually, just for transparency, this is in San Diego, and this is the new UI visuals. So don't worry if yours doesn't look like mine. Mine is just the new visual that we've got here in the formats. So the first thing I'm going to talk about is back end, the back end of the solution. And I'm also going to touch on, well, where's it seen in the system? So I'm going to talk about these. So classification, similarity, clustering, regression. This is how you get started. Now, out of the box, we give you a workbench. In this workbench, it has all your use cases. So when you look at use cases, you can see here, create new template. So we actually give you templates. So if you wanted to get started quick, what I always suggest to people is, remember, you can train a model and it not actually impact your system. So training the model just to see the results. So here, as you can see, I've got the full system. So here I can basically see, I can predict category for incidents. I can predict assignment group. I can predict HR. These are all guided, set up, built, ready to go. Okay, so I've got this modeling ability, this workbench, just to say, if I wanted to set up quick, I could just say, I want to do this one. I click start and it starts me off on the process. But what I want to do is, I want to take you through the long-winded process so you can understand how this comes together. So in the classification, you've got what's called solution definitions and solutions. Your solution defs are your designs, your solutions are the results. Now, what I'm going to do here, as you can see, I did one earlier for European webinar. So I'm going to open this one up because this is probably either trained or it's in the middle of training now. But what I'm doing is I'm actually basically telling this, I want this to train based off my data, my category structure. So what this is what it's going to do, it's going to basically set. Now, what I want to talk about here is understanding that you as the customer are the data handlers. We are just the data processors. Because when I say this statement, when you send a solution for training, it goes to our training server. Now, the training server resides in the same DC as your instance. So we don't load balance. We don't send it off to a different DC. It stays within yours. I don't know why my internet's a bit slow. I apologize. So what's going to happen here is that you're going to see that you're going to specify what information you wish to send to the training server. So for example, if you're building a model that's going to learn the category, okay, based off short description and description for 1 year's worth of tickets, and that 1 year equals 1 million, or let's say not 1 million, let's say 250,000, then it's going to send 250,000 tickets, but it's going to send the description, the short description, and the category. It's not sending the entire actual solution itself. I'm sorry about this. I don't know why my modeling's slow. Just let me just open up another instance just in case. Just waiting. Apologize about this. Just going to find one that I need. So I'm going to just sort by the incident table. So I've got incident, there you go. So categorization. So hopefully this one will be a bit quicker. Okay. So what you're looking at here is, as I was saying before, is that you're looking at the category. That's what your output field is. You're learning from the short description. You're sending, it's a small amount of records here, and this is created in the last 2 years. So what you're doing is, let me just edit this record so you can see it properly. So what this is doing is that's going to be sent to the training server. So that's the amount of records that are going to be sent. So as you can see, it's very, very simple. And as you can see, short description, category, incident table. Okay. Now what this is saying here, created on the last 2 years, active is false and state is one of resolved and closed. So it's only going to learn off those records. Okay. Now, again, you've got my processing languages, what I want to process the machine model in. And then I've got this training frequency. Now, this is my demonstration instance, so I'm only going to run it once. But depending on the volume of data that you're learning from, you may want to say, if I'm creating 60,000 records a week, you may want to run a model every 7 days. Because the more data it learns, the more intelligent it gets. Okay. So once it's got this, you can start to train the model. But then when your results come back, you end up with something that looks like this. So this is my category result. Okay, so once it's gone to the training server and the training is completed, it comes back. Now what you're then presented with is you can test the solution. So you could say mail not responding. I can do something like that. Give me the top result. So I can click run test. It's basically telling me, based off my modeling, software with a 96% confidence, and the threshold was at 65. So again, this is what it's telling me. But you see down here, my category structures are here, and it's showing me my models. So based off this is where you start talking about tuning your model. So as you can see, this distribution is telling me the volume of records that it had against that particular category. So what it's telling you here is the precision is that's how precise I'm going to be, my estimated precision and my estimated coverage going forward. So with a 93% precision, I'm going to be able to get an 82% coverage estimated going forward. Now, if I look at this one that was software, software here is a 96% precision with a 96% or 97% nearly coverage. But if I go inside of the software, you'll see it's giving me other options. So at the moment, I'm at 96.44, which is here, and it's giving me a coverage of 96. But what I'm trying to do is, if I push it up, if you look, the percentage of push up, if I push it up, so I'm at 0.44, if I go to 0.6, my coverage is going to reduce. So what you're tuning is here is you're saying for this category, you can be less precise or more precise. So what this does is by changing that model, and you can just change it by checking the box and a click apply the value. Once you apply the value, it gives you a bit of a heads up to say you're changing it. You click OK. Once you've done that, you'll then see that you're now at 96.6% with a coverage. What's that done to your model? Well, at the high level, what it's actually done is it's pushed your precision up, but your coverage down, because it's like the yin and yang effect. So this is all about the volume of data it learns from against a certain category, and it gives you this precision and coverage, but then it gives you the ability to be able to look at, you know, do I push the precision higher, or am I happy with the coverage, and so on. So this is what this does. So very, very quickly. Now, from the use case perspective, you can just go in and say, I want to create new from template. So calling the templates that you have, you can just say, I'll just use this way. So doing it this way, if I said a category, so if I said predict category, so same thing, I click start, give it a name, give it a model name, advanced setup, and I'm just going to basically say here, my advanced setup is, I want you to say last 2 years, I think it was in here because I've not got a lot of data in here. Last 2 years, active is false. Now you'll see in a second, when I step off, this will actually jump in a second and change. Is one of resolved and closed. And then if I go to here and then say, look at short description. So what this is going to say is, and if I wanted to do it in a different language. So this is what this is doing is false, resolved and closed. So you see here, I can click on this and this will give me a list of the records. So you can see here, it's 6,000 at the moment. So if I need to play with this a little bit. So if I said remove that and step away, it will change. So it will actually sort of say to me in a second, that's actually a lot more records, depending on the volume of data I've actually got in my system. So I've only got that many. So what you're doing now is you just basically say, train the model, and that trains. Once the models have trained in this instance, if I have any, here you can see predict category for incidents. So now what you've got here is start the model, test the model like we did with the tuning, and then integrate the model. So it's just an easier way of doing it. Now, what I always say to people is, where does this surface in the system? It surfaces in the system like this. Oh, sorry, minimize the wrong tab. So when you look at the back end and you see the modeling that it's trained, where do I see it? Well, from a classification perspective, if I go into a new incident here, and I basically say, I'm going to create a new record. Now, again, I'm going to say it's for Alvin, and I'm going to leave that. I'm going to set that to, well, I'm going to set that to, say, hardware. I'm going to send it to I'm going to send it to Acme Refrigerator Support. And I'm going to say something like Outlook not responding. Okay, that's all I'm going to do. So at this point, I'm just going to step off. Now you'll see something behave here, something appear. But at the moment, all I care about is I've set hardware, Acme Refrigerator Support, and Outlook not responding. And I'm just going to click save. When I click save, you do actually get prompted with a blue box that tells you it's made a prediction. But as you can see here, software and IT client systems engineering, because it's learned from your historical models. Now, this is also viewed in here. So here's one I prepared earlier. So even in the virtual agent, when I'm logging the calls, this was me logging a call a while ago, when it goes through the process in the VA, when it gets to this point, you'll see here it's created the incident. But again, I probably wouldn't show this to the customer. It's showing my modeling. This has gone to the software support group, been categorized as software, and it's been prioritized as 5 for planning. So again, learning from my model. So it's relevant here. Some customers also say to me, that's all well and good, but I don't use the agent workspace yet. Well, worry not, because it's in there as well. It's actually in the existing workspace, in the existing UI. So if your agents are creating records in here and they create a call here and they say exactly the same, say Outlook not responding, and I'll leave it blank here this time, and I'll actually set that to cloud management. Once I click save, you'll see immediately this will also kick in here. So you don't have to configure it differently. It's working where it should be. Okay. So you got a question, is Predictive Intelligence Workbench covered under ITSM Pro licensing? Yes, it is. Is it not showing up in our Rome? Right, now, if it's not showing up in Rome, it is there. So somebody's asked the question, Predictive Intelligence Workbench, is it available? Yes, it is, but they're not seeing it. Well, it gets overlooked so often. If you go into the plugins, and I'll just open that in a new tab. What you've got to remember is Predictive Intelligence isn't just one plugin. Depending on what you own, there's a lot of plugins. Now, I can tell you now, the Predictive Intelligence Workbench is, but you can turn on the Workbench and still not see the templates, because there's another plugin you turn on to give you your ITSM conversation, your ITSM stuff. Another question, while I'm just waiting for my page to load. Sorry if I missed it, but by coverage, do you mean the percentage of records that are predicted? Is it the measured numbers? Is it the measured in numbers or length of period? It's measured in numbers. So what this is saying is the coverage is going forward. I'm going to get, so if you've got 1,000, it's looking at the volume of records that it's learned from. I'm going to go forward. I predict 97% of these records I'm going to get right. And remember, if it doesn't pass the confidence threshold, it won't set the record. It won't set the field. So just coming back to this one on the plugins, it's dead simple. Type in predictive and spell it correctly. You'll see I get 36. Okay. Now, when you scroll through these, you see you've got all these different ones for predictive. But as you get down at the bottom, you've got the predictive intelligence engine. Then you've got all this stuff. It's really down at the bottom. There's predictive intelligence. There's predictive intelligence for incident management. You'll see there's 2 in there. If you keep coming down, you'll see predictive intelligence, major incidents, predictive, universal request. Then you get to the workbench. Now, under the workbench, you see if you click on this, there's the workbench, and there is ITSM content. So if you enable this one, it should give you both that one and that one. If you have HR as well, you can go down here and install the HR one. But if you've already installed the workbench, but you're not seeing the templates, if you see here, it can sit on its own, so you can install that. So that will give you that entire workbench setup. So that will give you this. If I go back. That will give you this workbench, and it will give you all of this as well. So this is here. Once you've enabled the ITSM one, you'll see all the created use cases. Okay, now just moving on. The similarity framework. Similarity, again, I'm a massive advocate. I've worked on a service desk a long time ago, and this for me would have helped me massively. So what I'm showing you here is how do you build it and where's it shown? How you build it is really simple, because what you're actually doing here is, if you look at similar open incidents, what you're actually doing is basically saying, show me similar records in the same table. So this is me building my model. In the incident table, look at short description and compare it to incident short description. And I only want you to look at resolved and closed. So what this does is it's got these records. Now, if you wanted to do similar changes, table would be incident, test table would be change. So this is going to say, when I'm creating a new incident, look at the change table and do me a comparison. Is there anything similar? So this way you could get similar changes. So again, the modeling is basically built here of doing comparisons. Training frequency, I've got it run every 7 days, update frequency every 15 minutes. But the only thing that's different from classification are these 2 fields and this corpus. This corpus is mandatory. So the corpus is, I always say, imagine the pattern of wordings in your organization. So you're putting a set of wording structures together. So when it learns your similarity framework, it's looking at how you're positioning word structures together in your organization. So when it learns from this, when it comes back, it gives you a solution. Now, very simple here. There's no real tuning of this. The only thing you can do is set your similarity threshold. So what you're basically saying here, it's the degree of similarity between 2 records. Records with a similarity score higher than the threshold below will be returned by the solution. So what this means is, if I test the solution, if I say Outlook is not responding, give me the top 5 results, run test. This is basically showing me, there's my threshold. These are way past the threshold. So if your agent was logging a call or searching stuff, I'm going to give them these ones because they're passing the threshold. If I then say something like Wi-Fi is down, give me the top 10. Run test. So you see here, unable to predict. Let me say top 5. Run test. So it's not giving me anything. Well, maybe my threshold, if I push my threshold down to say 60%, like so, test solution, Wi-Fi is down, is it going to give me anything? Still not giving me anything. But if I go back to Outlook is down, is not responding, and I say give me the top 10, you know, I'm seeing all other bits of stuff now that might not be relevant. So I've got 99%, which is still really high. So the only thing you can really do here is change this thresholding. Okay. Now what you can do in here, you can look at your examples. This will just open up your pages of showing you the similarities of records in your cases. So a question from Jess, should you use the same word corpus for all solutions? Or is there a reason to have a new corpus for a similar? No, you can. If you've created a word corpus for clustering to say, look at all incidents in the last 6 months that are only closed, you can use that for classification. You could use that for similarity. But just remember, it's pulling its wording structures from just those 6 months of closed records. Think of it another way. If you think about if I'm building a model to, let's say, look at classification, and in there, let's say, I'll give you, this is a silly example, but let's say you're a gardening company. Now, again, you've got a technical department and you've got a gardening part of this. Now, if you basically say to the corpus, just learn from the incident management piece. So in its eyes, a router is a technical piece of routing software information, so in your network. But if you've got a customer side of it, it could actually be an engine part in a lawnmower. A router could be the same thing. So if you're building a corpus and say, I want you to learn from the incident table, and I also want you to learn from the knowledge base. So your corpus can look at multiple sources, because it's the more wording patterns it gets, the better the modeling is going to be, because it's understanding your structure. But in essence, Jess, you can use the pattern, the cluster corpus, sorry, the word corpus across the same solutions. And I do that very often. Yeah, so what you'll do is, Jess, if you're building a brand new model, you are basically under the word corpus, you just click it and select it, and it will be there, because you actually build word corpuses separately. So they're actually down here. So they're actually in Predictive Intelligence word corpus. So your word corpuses reside here. And as you can see, I've done this quite a few times. So these are where your word corpuses reside. So all incidents, I've got articles and content tasks, articles and work order tasks. So I've got this looking at multiple things. I've got incidents and knowledge base last 12 months. So I can reuse that one multiple times. Just have to add it in when I'm building a new solution. So similarity, where does it present itself? Well, you've actually seen it, because if you're in the agent workspace, okay, over here, if you go down here and select similar resolved incidents, it presents itself here. So this, to me, is where an agent is logging the call. So let's say Jess, I'm not going to ask you to come off and mute and role play, but me and Jess is the customer, I'm the agent. I'm new to this organization. She's telling me what's going on. Now, normally I would say log the call and I'll call you back and I'll go and research it, because I'm new to the organization. So I might not know some of your intricacies. Now, I'm being presented with two pieces of information. The only piece of information I ask you to ignore is the hours. So let's say that says 1 hour. Now, I'm being presented with two sets of information. So by logging, I've got Jess on the call, on the phone, and she's talking me through it, and I'm being presented with information. Okay, let me just take a look at this one. Is this similar? And I can go into it, I can copy the incident resolution, I can look at the incident itself. But I'm also being told, imagine this, we noticed two similar high impact incidents have been created in the past 1 hour. Hold on a minute, is something starting to happen? I may need to propose an MI. So, thanks, Jess. So what we're saying here is the agent can be expedited. The agent can be told there's a major incident going on. So similarity framework is presented here. But I could also say similar knowledge articles. Is there any similar changes? Is there any open major incidents? So again, it's giving me all this information. Now, some people then say to me, cluster, I don't have the agent workspace yet. We've not deployed it. Well, again, you've already seen it because in the incidents table, it exists. So in incidents, and spell incidents correctly as well, if I look at creating a new incident, where is it? Incidents. Where are they? Show incidents. So if I want to look at new incidents, oh, that's not the one. Incident here. So if I look into any, it doesn't really matter. If I'm in this one, the similarity framework presents itself here. So if this is Outlook not responding and I go to similar open incidents, it presents itself here as well. So again, I can see that as well. Okay. And as I will stress, similarity is the quickest win you will get. Okay. So what we're going to do now is I'm just going to do clustering, because clustering is also a very powerful one. So under the clustering section here, exactly the same as building classification. What you're doing is you're building the model to be able to group your records. The results that come back look like this. So here you can see I've run this a few times. So if I go into this one, this is where I've looked at incidents, all incidents that I've got in my system. And I give my cluster visualization and it's grouping the records into clusters. I can basically then filter on these to then basically say, show me clusters with 400 or more. And I can then say, show me the quality of ones. The quality is the relationship of the record inside the cluster. I rarely work here. I sort of work down here. So what I do with this is the ability to be able to see where my clustering records are put together. And if I go into one of these, it basically just shows me what they are. So, and I just, this clustering model is just learning off just short description, but I could get this to learn off short description, description, and category. So the more data fields it's looking at and it's clustering together, this is one cluster with 198 in. If I built it to cluster on one field or short description, description, and category, I could end up with two clusters and these split between two different clusters, because the more information I give it, the better the clusters could be. So this is what helps me understand from a proactive problem management where I've got reoccurring issues. But I actually use this, and there is a addition, there's an update set you can apply that gives you what's called clustering analytics. Now, I love this because what this enables me to do is use our predictive intelligence engine to give me this set of records. And imagine doing this for yours. And let's say, for example, let's use our imagination that this one here is password reset. I can press this create recommendation button and it puts it into the my recommendation space. I can then make some calculations and then I can go to my bosses upstairs and say, hey, you know what we need to do? We need to put in these virtual agent conversations based on our data and it making some recommendations. We can potentially see the savings over a 3-year period if we put virtual agent in. So clustering is helping us improve our service, expediting our service, bringing it together. Clustering is very powerful, and I'm a big advocate for that. And then the final one before I just pause for questions, and hopefully you've all enjoyed this, solution of regression. Regression is exactly the same as classification, but it's numeric. So the actual design of it is exactly the same as classification. You're basically saying what fields do you want me to learn from, what fields do you want me to set. So as you can see, it's exactly the same. The thing of it is here is predict resolution I've gone for. So my output field is resolve time, short description, the amount of records I want to learn from. My modeling, once it's trained, comes back. And here I get a modeling. Now, again, there's no real fine tuning here. It's just your confidence level. So again, if I use that Outlook is not responding, set 80% and run test, it's giving me the worst case scenario in seconds, the best case scenario in seconds, and then it's making a point estimate. So I always do this for customers. Now, again, this is demonstration data, so age is a big factor for us. But this is looking at this. And what that then gives us, if I press this into here, which is there, it's actually telling me that it would be 56 days, which would probably be pretty disastrous if it was a live environment. But this is what it presents. Now, we have customers, well, I have customers that are utilizing this, that when a customer logs a call in the virtual agent can call this regression model and basically say to the customer, we're going to log a call, we're going to send it to the hardware team, and just so you know, this is going to take 1.5 days or 1.8 hours to resolve, our expected resolution time. So this is what regression is. It's more of a numeric, but it's not just resolve time. As you can see here, it actually can do temperature, stock prices, and so on and so forth. So that's what this is used for. So I've overrun a little bit here, so I'm just going to stop there, and I'm going to come back and I'm going to turn my camera on just to scare you all. So that's the core competencies. Now, remember, we're doing more live webinars and we're doing more, and I would ask you all, join the NLU one if you're looking at virtual agent, because there's a lot to benefit from that one. But I'm going to stop talking and just see if we've got any questions. I know we've had questions through. And Jess, thank you for the beard comment. Thank you. All right. So I hope you've all enjoyed it. I hope you've got something out of it. If there's no questions, just as I said to you, I'm just going to show my screen one more time. And this is what we're asked to finish on, is please be mindful. And again, I'm just going to go back to the slide I need. Please keep an eye out for the future webinars. We have got more coming. And again, we really do appreciate you taking the time. Have we got a question? So if there's no more questions, I thank you all for joining. Please take the feedback at the end. We do appreciate that. Hope to see you all at Knowledge. There's a Knowledge event in Vegas. There's a Knowledge event in The Hague, in Amsterdam. And there's also one in New York. I will be in the UK at one of our other events. But please, if you're getting along to the events, drop by, say hello. There will be members of the Now Intelligence team in all of those Knowledge events. So with that, I bid you farewell and have a good day. Take care, everyone.